All right, part of this lesson on humidity is being able to calculate humidity using those different tables. So if you missed this instruction in class or just want a place to review it, that's what this video is for. All right. So here's the idea, right? We did the psychrometer lab, or we're working through the psychrometer lab, and we get our different readings on the bulbs, and from there, then we can determine different kinds of humidity. We can find the relative humidity, we can find dew point, we can find heat index, we can find absolute humidity once we know those values. So let's work with that. So two numbers we need to remember right now are 88 and 77. Maybe write that down on a sheet of paper. I'm going to jump over to my table. All right, first thing we want to find is relative humidity. As I find relative humidity, I got to remember those two numbers that I had. And so I said 88, I'm going to put D for dry, and it was 77 on the wet bulb as we're looking at that. Okay. From here then, we got to kind of ignore the color because that's not the problem we're working with. But we see dry bulb on this chart right here. And so we're going to find that dry bulb, and here's our 88 right here. So we're going to use that to help us understand this. An easy way, right? If you're not good at lining things up on a complex chart like this, an easy way to do this would be to grab like a sheet of paper, right? Put an index card, anything like that. That's not what I wanted. Why did it do that? All right, this part of the video will be edited. Just fill it in. All right. The idea here is you can use an index card, right, to cover up what you don't need. So now I can take this card and I can line it up. So there's my 88. So now I don't see anything below it, and now I can just kind of follow this border right here. And then let's see, the second number I had was 77, right? So 88 minus 77 will give me my change in temperature. So 88, I'll write that right here, maybe. 88 minus 77 is going to give me 11, right? If you can't do that in your head, use a calculator. There's no shame in that. Use it. It's there. It's a tool, right? Use tools the way they're meant to be used. They're great things. All right, so 11. So that's what we call our wet bulb depression, the amount of change. And so here's our 11 here. And I just happened to leave this card here. But if my second card wasn't there, I can now take my card and go like this. And now I can just take my fingers and make my way to where they intersect. And the number would be 61. 61. So going back to my problem, here's my first problem. What is the relative humidity? I would say 61 degrees Fahrenheit, like that. Okay, so now that we have the relative humidity, right? Remember, we also have just this number right here, because it's the dry bulb, is just a regular air temperature. The wet bulb is the only one we're going to use this to find relative humidity. All right, dew point. Okay, so let's figure out what numbers we need. I'm gonna press some undo buttons. 61. I'm gonna get rid of some stuff for a minute because that purple is really messing with me. All right, so now we want to find dew points. We got to go to the dew point tables. Here's our dew point table. Right, you should have this sheet in your notes. If you lost it, whatever, ask for a new one. Dew point table here. And so we need to know the air temperature and we need to know relative humidity. Right, those are the two numbers that we need. Right, so going back to this page, let's see, we said relative, that was weird. Relative humidity we said was 61 degrees Fahrenheit. So there's our relative humidity. And remember that the dry bulb is the same as our air temperature. So we're going to need this number right here. So 88 and 61. So now I come down here. Once again, you can use the index card trick. And obviously my numbers are not perfect, right? They're tables I found, and so we can kind of just use this. So 88 is going to fall somewhere in here. So we're going to use, right, 88 is a little bit closer to 90, so I'm going to use this number. I'm going to use that row. And then my relative humidity was 61, so that's closer to 60 than it is to 65. And now I can just line things up and come down like, that's not what I wanted. Come down like this, and they're going to intersect right here at 74. And so that's going to be my dew point, right? And what does that mean? Dew point means that's at this temperature, it's 74. Oh man, I got it right in the right spot. That's the wrong spot. At 74 degrees Fahrenheit, that's where I could reach full saturation, right? Full saturation. All right, if this is what I'm getting from this heat index, what would it actually feel like? Right? What would it actually feel like? So once again, let's figure out what numbers we need for heat index. Heat index, I need relative humidity and air temperature again. So actually the same numbers as last time, right? So we actually need relative humidity, we said was 61. So that's gonna put us, we can use this value here. And we said 88, right? 88 was our number last time. So we can use this value again, and hopefully we'll get something that intersects. And we did. So this is another way you can use it. If you have a plastic sheet, you can put this sheet in there, and then you can use a dry erase marker to do this if you don't have index cards. But here we go. 100 degrees would be our heat index table, which means that if you went outside on this day, this was your air temperature and this was your relative humidity, it would feel like it was 100 degrees outside. That's what it would feel like, okay? Now, the last idea is absolute humidity. That's all about understanding, well, how much water is actually in the air. That's what absolute humidity is all about. And so, where's our absolute? Absolute humidity is this table over here. And once again, we need relative humidity and air temperature. Isn't that nice? We find it with our psychrometer, we find relative humidity, and then we can figure out so much more based off that. So these numbers look a little different, right? They look a little different, but we can look at relative humidity, right? So relative humidity is 61%, so I'm gonna use 60 again. And our air temperature was close to 90. This box is in my way. Let's see if I can move it. There it is. All right, box is in my way. And now I can solve this problem. I can make these come down. And we can look at that in 8.07. 8.07. And so if I go back, I guess I gotta go back and fix my answers because this is just a percentage. That was my mistake, not your mistake. I just was trying to go too fast. That's a percentage. That's right. Are those right, or are these all percentages? No. What am I thinking? Dew point. I gotta rethink my labels. I'm second guessing them. Anyway, we got this 8.0, where did I put 8.07. So that's the amount of water. So that would be 8.07, I believe it's grams per kilogram. Is that? I know this one's right. Dew point, is that a temperature? Let's go back. Yeah, dew point is a temperature as well. All right, that's how you do it, right? That's how you do it. Walking through, finding those numbers, using those charts. It's really just about using the numbers you have, lining them up, plugging them in. All right, here's another one. All right, if you don't want another example, press stop and you're done. All right, if you want to walk through it one more time. All right, here I go. I'm gonna walk through it one more time. Let me erase my stuff. All right, example problem number 2. So we got 64 and 59. Those are our two numbers, dry bulb, wet bulb. Remember, dry bulb is the same as our air temperature. All right, so we'll want to keep that number in mind because we're going to use that for dew point, heat index, and absolute humidity. But for now, we're going to jump to our first table, which is this one. 64 was our dry bulb, and our wet bulb was 59, right? So 64, excuse me, 64 minus 59, that's the change in energy on the evaporation, right? So that's going to give us a value of 5, right? So here is our value. Index cards, draw on your sheet as much as you need to, and that gives us to 75%. It's actually a higher number than last time, right? But remember, lower temperatures means they just don't hold as much. So now we're at 75% humidity. So 75% humidity, relative humidity. What's that going to look like, right? How full is it? What's it going to feel like? Let's figure that out. So now that we have that, right, we're going to use 75% and that's 64 degrees Fahrenheit, right? So what do we say, dew point? All right, dew point next. Relative humidity was 75, so that's this. 64, that's close to 65, so I'm gonna go, whoops. That's the right row, my circle moved. So dew point is gonna be 57 degrees Fahrenheit. So at 57 degrees Fahrenheit, that's when it's going to be full, all right? So if the temperature lowered, it would be at 100% with that amount of water. That's what that means, okay? So 57 would be our second answer for dew point. Next one would be heat index. I'm just gonna jump right into these. So 75% and air temperature is 64. Oh no, it doesn't compute. I gotta find a better table. All right, maybe I gave you a better table. Let's just go down. Sometimes you can kind of guesstimate because you can kind of see a pattern in the numbers as they're changing, right? They're kind of going down about the same as you're working with this. But if we had one, it would go like this. What a horrible example. It would be like this, 64, 5 degrees less. So every 5 degrees, it seems to go down almost 7. So it's not really gonna feel too different, right? It feels like 64, right? And even though it's 75% humidity, it's actually gonna be lower than this number right here. It's gonna feel like, it could be 70, could be like 68, could be very, very close to just feeling like 64 degrees. I gotta figure out how to make this problem work. That was a bad number choice. Bad number choice. But that's the idea. That's how you would have solved for that. If I think that all my problems fit within these charts. Now I'm second guessing myself. All right. So it's gonna feel almost like it's probably like 66. That's my guess. That's my educated scientific guess based upon how the numbers have been dropping as we're looking at that. So almost exactly the same. All right, last value would be how much water is actually in there. So 75% is here, and 64 is about here. So I make my way. So 4.35 grams per kilogram. So a lot less water, even though the percentage is higher, because the capacity is lower. All right, if you have questions on this, sit down. I'll gladly walk you through any of this stuff.